Hi guys, welcome back. So today we're going to be looking at a complex familiar example from your textbook on how to integrate using partial fractions. And I've chosen this one as my most complex example because it's completely algebraic. There's very few numbers involved here. But what we do know is that A and B are elements of the real number set and they're not equal to 0. Now, having a look here, this actually looks pretty familiar. This actually looks like the difference of two squares. So I can use my difference of two squares rule to factorize this. So I've gone ahead and I've just written out each of these partial fractions. So we're going to do the same thing as we've done in every single example. We're going to cross multiply so that I have A multiplied by BX minus A over BX plus A, bx minus A. And then we need to also cross multiply for B, so that we're going to multiply this by bx plus A. We've got to be really careful here because a lot of these terms are very familiar. But hopefully you should be able to appreciate now that the denominators are going to be the same. So what I can do, if I rewrite this, I can multiply by bx plus a over bx minus a, and that will eliminate my denominator. Now what we would normally do is we would normally substitute in some value here to get one of these brackets equal to 0, because that would eliminate that term, and then we would be able to solve for a and b. So let's go ahead. We need to let bx take away a equal to 0. So in other words, bx is equal to a, and so x is going to be equal to a over b. So if we substitute x is equal to a over b, that will eliminate this a term here. Let's find out the value for b now as well. So we need to have a bx plus a is equal to 0, and so therefore bx is equal to negative a, and then x will be equal to negative a over b. So if I substitute negative a over b, that's going to eliminate that b term. Let's go ahead now and let's substitute those values in to determine a and b, the capital A, capital B. Now keeping in mind this lowercase a, this is going to be some real value or some real number. So we've got b is equal to 1 over 2a, and then capital A is equal to negative 1 over 2 lowercase a. Probably should have picked some different terms just to make it a little bit easier for myself. Oh well, let's go ahead anyway, and let's just substitute those back into our original expression. Okay, and so now we're just going to find the integral of each of these. So again, what we could do, because we know 1 over 2a is actually going to be a value, we can pop that out the front here. So we have the integral of 1 over 2a multiplied by 1 over bx plus a dx. And that's going to make it a little bit simpler for us to integrate this. We could also really factor out this 1 over 2a completely out the front here if we wanted to do it that way as well. So bx minus a dx. All right, so let's go ahead and let's finish this integration now using our integration rules. Okay, so I think this was a pretty straightforward integration process, and then I had sort of an explosion all over the screen. So I'll just sort of walk you through what I've done. And again, I've just popped some colors in just to sort of help you to see what I've done. Sorry, guys. Okay, so like I said, first thing I did, I factorized out that 1 over 2a, and then I was left with the integral of 1 over bx plus a dx minus 1 over bx minus a dx. And then I've just gone ahead and done integration using substitution. I've substituted in u for bx plus a, and I've substituted in v for bx minus a. And then I've just gone ahead and done that integration and then just rearrange that using my log laws. So this is actually something that probably would take a little bit longer than 4 minutes to do. It's just that I've sort of broken down that process sort of step by step for you, and I haven't showed you all the mechanisms. So realistically, I think this question on an exam would probably take you anywhere from 10 to 15 minutes. So that's why I think this would be a complex familiar, moving into complex unfamiliar, depending on the context of that particular question. Alrighty guys, I will leave it there for you. I did enjoy this problem. I do love a little bit of algebra, so I hope you enjoyed as well, and I'll see you in the next video.